Hello, everyone, and welcome to another K6 Office Hours. I'm Nicole van der Hoeven, and today I'm with two people who were saying funny things right before we went live. Would you like to introduce yourselves, you hooligans?
Sure. I'm Paul Balogh, developer advocate here at K6, and we try to make Nicole mess up. So we try.
Very successful at it too.
I think so.
Today we also have Daniel González Lopes, who has been here before and has a very long name. Daniel,
Really?
why don't you talk to us about your new role? Because I think the last time you were here, you didn't have your new role yet.
Yeah.
Yep. I was working as a site reliability engineer, and now I am a technical program manager. As Nicole likes to say, I manage programs with my keyboard. But in all seriousness, now I work more closely with product and all the engineering teams in just shipping things and big efforts inside the company.
You get to define the future of K6.
Yeah.
Good.
Yeah.
So what does a technical program manager do exactly?
Mostly that, as I said, collaborating with product, these big internal efforts that we have, trying to, get engineering and product to agree and just work with both teams in shipping good things. Making good open source products and good Kisses Cloud additions. That's mostly.
Okay, but even before that, you're a site reliability engineer, as you said, and there are, to some extent, like, it's not like you're completely leaving that. You're just taking a little bit more of a strategic approach to it, I guess. How do you feel about that?
I feel positive. I have wanted to learn more about product and more high-level things for some time now. Something that has interested me like a lot. The switch isn't that big because I feel that I become like from being like the customer, like because as an SRE I was kind of the target to some degree to help draft that future, right? And collaborate with, for example, Mark from product and other engineering leaders in building cool things. That's really cool.
Okay, can you tell us what do you even mean by observability, and why do we care about it at K6?
That is the loaded question.
That's why I'm giving it to Danielle, Paul.
Yeah, exactly.
You're starting hard.
Yeah. Come on, this is like your fifth time. Hand-holding is over.
For me, observability is just about, having more transparency in applications, being able to better understand what's happening, being able to really be able to answer the questions that you need to do, right? For example, I want to know how many users are using this service, or I want to know more technical things like how much CPU, how much memory, the usage of this function, error rate, all these things. Observability helps you dive into that and more with these, complex beast of systems that we operate in these last times with tons of microservices. It's just about increasing what we can see on the surface of questions that we can ask. That's my answer. People have, different definitions of it. Maybe Paul has another one.
Well, I was just going to say we still have about another 55 minutes to go. That can't be all.
We can wrap up here.
So I think with observability, a lot of people, when we were acquired by Grafana, it surprised me. We got the question like, oh, but what does that have to do with performance testing or with K6? But I think that's very indicative of where we are as an industry, that it used to be completely separate. At least that's how I viewed it. As a performance tester, observability, like, it existed, right? This is not an entirely new concept, but I think that it hasn't been as as intertwined with performance as it was in the past. At least that's not how I learned it. Ooh, we've got Sima in the chat. Oh, I mean trader, Sima, trader. Hi, Sima. What do you think, Danielle?
About Simon. Nice guy.
When
you come back?
Here too.
I'm waiting for you to come back.
Yeah, about observability, Danielle. Focus. Observability and performance.
Yeah, so fully agree with what you said, right? Coming back to the topic, this has been like this historical division of, for example, in performance testing, only taking a look at this black box data. That, for example, the load generator has like this view from the outside of the system under test, and I feel that observability is just a good complement to that. I mean, it's just about taking a peek at what happens internally at the system. I don't know, checking what your test was really doing, how that internal databases was struggling, or just being able to dive into that.
And ultimately, it's like to be able to react, so we can ultimately create some automation around that. So, with the load testing, we can see what the behavior is going to be, so that when we start seeing that fingerprint of the activity, then we can have automation in place to react to that. So it's all about, so you don't have your SREs having to wake up at 2 a.m. to, try to run through logs and try to figure out what's going wrong because this alert just went off.
Yeah, they complement very well, I think.
No, definitely.
So when we talk about trends in any industry, I feel like behind the trends are always some sort of pressure that's driving innovation in that industry. So before we get into the trends themselves, what do you think are some things that are creating that pressure for observability in particular? Like, how have things changed?
I think complexity, in multiple ways, right? A lot of this complexity comes from having huge teams or multiple teams. That's one thing, right? Then teams start splitting into microservices, having, also people wanting to adopt these distributed architectures, having more database, more components. Is just a mess, right? Maybe in the past, having a monolith was a bit easier, even though I think that observability is equally useful in that case, right? But now that the network is in the middle, it just feels that it's even more critical than earlier.
Yeah, definitely. As things are broken apart and split up, and definitely a hell of a lot more complicated. And then it's a lot of cognitive overhead for folks to try to operate all these systems when you have so many different applications that depend on each other.
Yeah, I definitely think that we're seeing the pendulum swing back from, well, first we saw it swing from monoliths to microservices, and then it's like kind of coming back, not entirely, but it's no longer like, a bad word.
We can call them mini lives. Mini lives are macro services.
Yeah. And I also think that, like, you're talking about complexity, Danielle, and I really like how you thought of it. You phrase it in terms of the team, like distributed architectures need distributed teams, and that's also a really good way that the industry has changed. But also just general fragmentation. There's so many new protocols and frameworks, and we still have to make all of those observable, right? And that's tough. We still don't have this unified observability picture.
Yeah, now with more production ready pieces, like in the wild, in the open source world, for example, databases, queues, like all these things, if they emit, telemetry that is a standard and that make it more observable, it's easier to adopt and people can leverage it more. So, you not only go like these huge systems only from your own code, but you also need to rely on all these, third-party systems and tame them into, behaving reliably on how you want. So, yeah.
Yeah, and I also, Simu was saying like macroservices, love it. Also, like I feel like it wasn't so long ago that we thought of things in terms of the application. Everything's in terms of the application stack. Everything serves the application. But now there's such a thing as a testing stack and an observability stack, and they are like systems in themselves that also need to be performant, that also need to be tuned, and that is both a good thing and a bad thing. It's good that it can do so much and is so sophisticated, but it is also more complex.
Yeah, and also that some people think that, observability is just about picking some kind of telemetry, for example, metrics, and adding them to my application. But it's more, right? It's like giving visibility in all those layers. So, for example, you need observability in your network stack. You need observability in your Kubernetes. Like, you need that in all the layers.
Yeah.
If not, how the heck are you going, to troubleshoot issues when you face them? So go ahead, Nicole.
So Sime has a question. If you don't already have it on the agenda, we did. I want to hear what Danielle has to say about eBPF and production profiling. Is it finally going to become a thing this year? Exclamation point, question mark.
Good question. I can't see the future for good or bad. Also, yeah, maybe we can touch in some of these topics. So, just maybe as an introduction for maybe people that are seeing us and are not familiar with observability. When people refer to observability, they a lot of times just speak about the ways on how you can implement that. And usually that's with different types of telemetry that your application can expose, and you can, get different vibes and different things, information from them. Most common ones are metrics, logs, and traces. Usually metrics are really cool, to understanding the what something is happening, like, hey, is my request rate okay? Is my error rate okay? All those things. Logs are for really understanding, why something happened, and traces are really good to understanding the where. And as Sime pointed now, there are like one new type of maybe telemetry that has been trying to get into the market lately, that is profiling. Oh yeah, you're sharing it again.
Yes.
I'm truly excited about profiling, and I think that it's very useful to have, deployments with continuous profiling, really understand, for example, which parts of your program use the most CPU, and keeping track of that over time. Just not only for maybe cost savings, but also for seeing how that impact the reliability and the experience of the user. So I truly think that profiling is coming there. There are a lot of investments, like from a lot of companies, and I truly think that it's going to be a really cool complement to all the other three telemetry stacks. Wanna say something
was
about
saying that? Sorry, Simi was saying that Charity Majors and Ling Fong Jones also say that observability is being able to ask questions about the state of a system that you didn't even know you'd want to ask. Because I think the old way of doing things was like, think of the things that we are going to need to look at, and then basically hit record and start collecting that information, but this is like, the switch in TV, how it used to just be like all live and you have to click record just to be able to capture something. Now the expectation is that these things are all recorded. Like if we use Netflix, you should just be able to go back and say, oh, what was that last episode again that I didn't catch, but maybe you didn't know about it till Paul just told you about it today, It's kind of like that, right? Like it's having things in place so that when it occurs to you, then you can go back.
Yeah, exactly. I'm
But
not
can you
doing it. I just want to add on that what Sime says is not, maybe in the past it was about, hey, this HTTP request failed. Let's go here and add, some if condition, and if this happens again, let's track it. is more or less, moving into having this breadth of data, just instrumenting your HTTP APIs. So any failure that you are going to have from now on, you can really understand why that happened, and not go later, right, and try to instrument it and try to reproduce it. It's already there.
Yeah. But yeah, going with that, the comment as well, it's one of those things too, as you start providing some of these metrics, and then you start throwing up your, your fancy Grafana dashboards that you display on those big wall TVs as you walk by, you can see that. But then, you might have a system that's actually behaving correctly as far as but then you just start seeing some of the patterns of behavior, and then it's like, well, that's kind of weird. Everything seems to be fine, but why is it doing that? And then you can start looking into those things that seemed perfectly normal, but then it's like, oh, wait, that starts getting you drilled in and asking those, those questions that you didn't know to even ask, to dig into those things that they may be a problem, they may not be a problem, but it opens up new questions for sure.
So I was going to tell you, before we can answer Sima's question, can you explain what continuous profiling is? Because honestly, I'm not sure I know what it is.
Continuous profiling, in very high level, can be done in different layers. The most common one is CPU, and it's mostly about measuring the time spent by each, depending on the language, like the time spent doing like certain operations, like different frames and all that. Just capturing that and exposing that data. That data can later be rendered in something that usually people do, like a flame graph that lets you really spot, like this piece of code is the one that is really taking all this time. Continuous profiling is just a matter of collecting that data continuously.
Yeah.
So, having a pool of agents or a pool of things, just pulling this data, storing it. So later, when your application was eating all the CPU, you can really understand why that happened past week.
So why is it considered a different type of metric? Because you also have a metric that is like CPU utilization, right?
Yeah, it's just the way of exposing the data. So, for example, metrics, as you know, can be of different types. They can be histogram, gauges, counters. Logs are a timestamp and a message. Traces are really cool, like these spans coupled together, linked all in the same trace. And profiles is just, a different representation that really suits all those small measurements of all the, CPU usage or memory usage or all those things.
Yeah.
Okay.
Yeah. I mean, I feel like it's almost just kind of like marketing speak, honestly. I mean, because we've already been doing all this, profiling. It just means that, we're continuously doing that, and then maybe establishing your bounds of, good operation, I guess, your baseline and your, when something's happening, and then just making sure that everything over, like maybe a 5-minute window continuously is operating within those bounds, so then everything's okay. But it's they always have to think of a new name to give something, so make it everything old is new again.
Yeah,
that's why I'm waiting to become new again, me personally.
Oh. No one's as new as Danielle.
Yeah.
New, but more experienced than most older people.
Thank you, Nicole, for clarifying. No, but I mean, profiling, as Paul says, is not like a new thing. In fact, if you put, profiling and your language name in the internet, you are going to find probably a lot of implementations of profilers. Even, Go can expose pprof, like profiles in pprof format. So I think it's mostly people, understanding the value of doing that continuously and trying to unify all those languages in some, standards and being able to get that data and crunch it.
And the profiling really does go to a deeper level where you can see how much time is spent in a specific, function if you take it to the code level, rather than just overall with a CPU metric or memory. So.
Okay, well, that kind of sounds like it sounds very similar to distributed tracing then. So I think they are both trends, but I'm still confused as to where exactly the lines are between these things, because metrics sound like continuous profiling, but just like the bigger picture of it. And then distributed tracing sounds very much like what you just said, Paul.
Yeah. And then Sime is adding in there. Let's see. Bring that in there.
He should just be here.
I was just gonna say that. It's like, we should just add him to the screen. He can he can help us out. But yeah, it's adding that extra data. I mean, it's really.
Yeah, I mean, that's just a need. Maybe I mean, the end goal is the same, right? Like just enriching the view that you have for your application. So yeah, there are just different thoughts on that. I know that, for example, the OpenTelemetry folks have really, or the special group for observability of the Cloud Native Foundation has ideas on what's a signal, what not, what's a telemetry type, these things. Yeah, I can agree with you, Sime, or not. It just depends. I have strong opinions on calling like it a signal or not.
Yeah, I think, like Paul said, it's kind of clever marketing. It seems like repackaging things that already exist in a different way. Who's this stranger?
Hey, so sorry about crashing your party. Of course I want to.
Yeah, what are you doing here?
So happy to be able to catch you all for once.
Yeah. So why don't you introduce yourself for those who are wondering why I'm calling you a trader?
So my name is Simon. I'm the trader. I used to be the colleague to all of these guys. But since about 10 months ago, I joined Canonical to do observability there.
Hence the tradership.
Yes.
So, Sime, what do you think continuous profiling is?
No, as I wrote in the comment, I mean, to me at least, it's not really a completely new signal in the sense that it would deserve its own, its own data format and its own all of those things, but rather just in addition to the already existing telemetry signals. Like you have a distributed trace, you add profiling data to it, you derive some metrics out of that profiling data and augment it with that as well. You maybe provide some exemplars of some sort, and you really try to build this coherent story with more meat than you'd be able to using only the traditional toolkit.
Yeah.
Okay, so now we have 4 different pillars. Is that what we're saying? We've got logs, metrics, traces, and now continuous profiling?
I don't like these pillars definition, but it's like if you don't have the 4 of them, your house is going down or something like that. I don't think that's true, right? I mean, different applications, different requirements. These are just tools that you can leverage maybe for your application. Logs and profiles, good enough. That's it. Maybe for another person, metrics and I don't know, traces. It depends, right? I suppose your maturity, all these things. Yeah. I don't think they are a requirement, personally.
They make life a little bit easier, though, for sure.
Yeah, I mean, obviously, it's easier if you don't store metrics as logs, but if that's what you want to do in Loki, you can create metrics from logs. So there are other options, but it just depends.
Yeah. And that I think is quite common as well. I mean, if you retrofit an existing system where you might already depend on logs, for instance, that is probably the most common way to output information about the system, that you would take those logs and transform those into metrics so that you'd be able to act on them in a more deterministic fashion than just regex parsing for certain keywords and going critical in case you find that specific keyword.
Yeah, but I mean, I think there's also like a difference between what is the minimum viable product, because you really don't need anything. You can technically have an application without anything. It's just not best practices to do so, right? It's not going to be very sustainable or any of the illities, you know. So I think maybe this is just indicative of what we were saying before, that things are so complex now that this trend of continuous profiling is just another symptom of how much we need that extra information, because we just need a bigger picture, and there's so many different sources of it that maybe it's better if it's like packaged up together and it's more meaningful.
Yeah, I agree. But even if there are these best practices or things that people agree that metrics are best for this, logs are best for this. For example, if you're a company that has none of this, I wouldn't suggest applying all of them at the same time. It doesn't make any sense. Like you don't have observability, or, and you want to implement more types of telemetry at the same time or whatever. That's just a bit crazy.
Yeah.
You need to start with the easy things, right? You need to expose some logs. Everyone can do it. It's mostly right? And work from there, I feel. So yeah, that's why I say that. I don't like this idea of saying, hey, these are pillars. You need all of them.
Yeah. Well, and then there's like, so, with tracing, for instance, that really only makes sense if you have like distributed microservices that are, have, the originating request is going through and then it goes through, 4 or 5 different services or something on that one call. But if it's a monolithic application, tracing is not any kind of a help, not in the sense of something like using a Zipkin or Jaeger tracing. It's not going to buy you really anything because everything's internal, other than the database calls and things like that.
I differ on that. I
No?
feel, yeah, even that with tracing, you can, it's not only about auto instrument. You can manually instrument what you want to measure. Maybe
Well,
you
you
want
can
to,
put custom spans inside the
yeah,
monolith. Yeah.
let's say that you want to track this flow, that the customers are the one that is like the most used. You can really track all the steps on that flow, right?
Yeah.
And get that data linked
That's
together.
true.
So,
True.
but yeah,
And also creating traces out of the profiling data in that case, because it's very interesting to know, like, okay, so this particular function is taking 80% of the execution time of this particular call. Maybe I have some optimizations I might do there to increase the performance of that system, or like apparently my database is under provision because I spend so much time waiting for the database to reply with some data.
Yeah. Maybe you're not connection pooling or something, and you're being bad with your connections.
I feel like the strength of all these things that we're talking about is that understanding what they do, when they are useful, and really knowing how to integrate them gracefully in your project. I mean, if you know that, you can pick and match what better fits your services. So all these things.
And also, like, all of these things come at a price. There's always an overhead for all of this, whether that's like needing more people needing experts to know what they're doing and to set everything up and keep things running, or also like the monetary cost of these applications or servers that are collecting all this data. I mean, there's always a price to this. So it doesn't make sense to just get absolutely everything unless you actually think you're going to be able to use it.
Yeah, I think one thing that people usually struggle with that they should probably try to do more of, and I'm sure Daniel will call me out on this for missing a point or something, but is to start with their actual failure modes. Like how will my application likely fail? What are likely ways that my application will fail? Try to instrument around those with the signals that make sense for those particular cases, and create a robust set of alerting rules so that you can actually go to sleep when you're on call, and you will know that you'll be woken up if something goes south, and really try to focus on that rather than trying to add a whole arsenal and make everything super shiny from the get-go.
Yeah, definitely.
fully aware. No interjections
Wait,
here.
I just realized, Danielle, can you describe for people what distributed tracing is? I know this has been a focus for you recently, so I'll let you do the describing.
Yeah, so distributed tracing is just it's just a lot of operations tied together by some ID. That's maybe the shortest explanation that I can give. Each one of these operations can have a parent. It can have kind of a song. It has some measurements, how much time it took. It has a name, and you can append all kinds of metadata into that. Distributed tracing is usually something that you need like to instrument your applications with some code or some auto instrumentation to expose all this data. Then that's gets collected in some backends, and you can render this data, compare it, process it, do all kinds of really cool stuff with it. As Paul says, it's really ideal if you have multiple services, probably managed by multiple teams, and you really need to understand, for example, we are not all Netflix, but let's say that you want to play a video on Netflix, probably that touches how much? Hundreds of services. Really understanding like all the actions, all the cascading of actions that really happen from pressing one button, being able to, know that over time, crunch that data, understand how this flow progresses, if your capture rate increases, decreases, your data is like everything is linked. It's a really cool type of data to understand the where of your system, I feel.
I think the last time we had you, Danielle, talking about distributed tracing, the way that you described it, or maybe how I understood it, is it's kind of like those things in your car that when you pass by like a toll, it goes beep, and then it captures like where you've been, and then when you pass another point, it's like beep, and then it knows, oh, you went from here to there. This is an element of directionality to it, right? Because logs and metrics, it's like they can be very separate. It doesn't really describe direction, but tracing does. It's like it's following where you went.
I like that metaphor, but I think Shime was the one that said that. And I agree with it, but I would like to give credit on that.
I don't
Another one
remember.
that I really like is that most people can probably relate to is if you fire up your developer console in, say, Chrome, and you go to k6.io, of course, the best webpage on the internet, and then you click the performance tab and you reload your page, then you will get a nice flame graph showing you how everything is taking different amounts of time and how there's steps to everything and how there are sub-operations to each operation and things like that. And you can really drill down into what makes up the loading time of my particular web page and what is actually happening there. Distributed tracing is the exact same concept, I would say, but you are instead applying it on something that is not just a web page that you're loading in your browser, but a very vast set of services spread maybe across regions, across continents, or just operating in different languages, where you'd still be able to follow that thread and see, like, as you say, Nicole, the directionality of it and what, how it works and why.
It's really cool because last time I showcased some distributed things to some frontenders here at Cases. They said the same thing. Oh, this is, the
network
Chrome view
panel.
for yeah.
Yeah.
It's really nice.
This is what Paul is saying. Everything old is new again. Like, this is not a new concept. It's just been repackaged, and then like the marketing around it is like fantastic. It makes you get that FOMO. Like, oh, I don't do that. I need to have that.
Exactly. Let's talk about service-oriented architecture. No, it's
Yeah. So what are some what are some other trends? So we've already talked about continuous profiling and distributed tracing. What else do you all see as things that have emerged in the last few years?
I think one that for me is obvious is that observability is, becoming more mainstream. It's true that before, maybe for some people, it was like this draconian thing, or some people were only familiar with logs and metrics. But now the whole idea is, of making your software more observable, being able to better understand what's happening. I feel that people are more on board with that and with the tools. Efforts like open telemetry with all these standards suppose try to bridge that gap, solve the pain points. Also, the open source space is more alive than ever. It's not only because I work here at Grafana, but Loki, Tempo, Mimir, all of them are excellent backends for storing those kind of telemetry, as others, right, in the open source space. But there are a lot of tools now that maybe there weren't there like a few years ago, and that's extremely cool.
Yeah, I always think about the whole service mesh thing. Hashtag service mesh. You have your products like Linkerd and an Istio with the Envoy proxies and everything, and that's trying to it's bringing in observability, but it's trying to make it hands off for the developer, so you don't have to actually instrument your application code, that these proxies by, intercepting all the traffic going in or out is doing that for you to try to give you a standard thing. And that's definitely something that's just come up in these past few years as well.
Yeah, the
It's kind of like what I
as
was.
well are kind of fun to have a look at it. I mean, it's not that hard nowadays when you start a new project to just import a package in basically any language.
It takes care of it. Yeah.
I was going to say, it's kind of like what I was saying earlier about how observability is its own system now. Like there's such a thing as like, now we're talking about the ergonomics of our observability stack, not just the application, not just how user-friendly that is, but how developer-friendly, how engineer-friendly is your observability stack, because it's just so complex. I mean, I feel like that all the time. I feel like every time I look into any big vendors offerings that closely, including Grafana, by the way, just because I'm there doesn't mean like, I just feel like I keep finding new things that I was sleeping on. And one of them is like eBPF. This is like a whole new thing for me. Apparently it's been going on forever and I've just like missed the boat on it and I'm still trying to catch up, but now it's everywhere.
It's fun because eBPF has like how many years? 10? 20?
Yeah, but like how much of that was it actually usable and useful? Like by the average person that's not, knee deep in it every day.
Yeah.
But it's definitely, as Paul says, I mean, I went to KubeCon in Valencia this year, and the hottest topic this year was, I would say, except eBPF, then it was software bill of materials, SBOMs.
Yeah.
And the traceability.
Wait, tell me about that.
Yeah.
Yeah, it's basically like, okay, so I'm building a piece of software here. Exactly what dependencies do I have all the way back? What version, what hash commits maybe, or things like that. So you'll be able to reproduce
What is
and
it called?
trace.
SBOMs.
Yeah.
SBounds.
Bombs, BOMS.
Bombs.
Yeah.
So it's short for software bill of materials. So basically, like when you build a house, right? You have a bill of materials with all the things you need to build a house.
Yeah.
The same, but for software. That seemed to be the next cool thing. And it's like Paul says, that's been a thing for so long. It's just recently gained popularity again.
Yeah, I mean, because of some of the security issues that have come up. I mean, me coming from a Java background a while back, I mean, it was the Log4j issue. Well, Log4j was a utility library that, I mean, almost every single project used. And then here, all of a sudden, there was a security vulnerability that was big, that was discovered. And then everybody's like, oh, man. What all applications do we have to immediately fix because it was such a bad thing? So that's why, because nobody had these SBOMs, it's your food label, it's your ingredient list that, to go and patch all these systems, it became obvious that we need something to track this. We have to be able to react quickly as vulnerabilities are discovered. So.
That is probably something that's going to become a thing in the future as well for observability. Like, okay, you have this bill of material. How do you integrate that with your instrumentation monitoring? Can you, for instance, say that, okay, out of this farm of 25 pods that are running the same Docker image, 10 of them have this vulnerability and have not been updated to have the latest dependencies. So those are at risk, and we need to fix those and roll out new ones immediately.
Okay, I wish I'd been able to go to KubeCon. Maybe I would know about S-bombs too. But I like that. I like that you're saying about the ingredient label, like knowing what's in it, what's in a piece of software. But it just seems so like does it really have to be called that?
You have to
I don't
market
know.
it as something, right?
I know. Yeah. Okay. So S-bombs apparently are a trend that I didn't know about. Tell us about eBPF.
Go ahead, Signe. Do the intro. I did it for profiling.
But it's basically related, right? So I'm not a big expert on eBPF for sure. So I only know it in like layman's terms still. But to my knowledge, it's a lot about instrumenting the kernel rather than instrumenting individual systems or individual processes. So say, for instance, that, okay, I'm adding a kernel module for being able to do these profiling and this tracing like on a kernel level rather than in the software that I'm packing. Does that make sense to you, Daniel, or am I missing the point? Feel free to.
Yeah, I mean, more or less. For me, eBPF is just another way of maybe getting information. In eBPF, you can write some kind of a small program that reacts to events, and you can hook to like an event source to consume those. Those events can be, kernel proofs, as Ime said, or they can be user space proofs. Maybe, I want to hook my program on this SSL library. So every time this happens, I get an event and I can process it, stuff like that.
Because that is kind of the point as well, right? That as opposed to other things in the kernel, you can really write and change these eBPF programs on the go without having to recompile the kernel
Exactly.
Or restart your computer or anything like that. So you'll be able to hook into a piece of the kernel and add application code there at runtime, which is just something we've not been able to do prior.
Exactly, it's really, really cool. And the kernel exposes like all these proofs and says to you, hey, you can hook into any of those, get data from them, and you're going to just receive events for every new TCP connection. Okay, here you go. This information, and that's, as Ime said, it's quite useful. You don't need to recompile the kernel to do your magic. This provides, people just writing software that can be hooked to another software without having to touch anything. That feels magical sometimes. It's really cool.
And that is also one of the trends that I've been seeing this year, that given that observability is becoming more and more commonplace now, it's not really as innovative or like novel as it was a couple of years ago. Things like turnkey-ness to solutions, as in how easy is it to get started? Can I just turn a key and get started with whatever it might be? That is really becoming a thing now. Grafana Cloud is doing that excellently. K6 Cloud as well. I know Observatorium is doing it as well with pick and choose components from the open source landscape. We are doing it at Canonical as well. So the barrier of entry is becoming really, really low now. You're able to do basically a one command deployment, and you have an observability stack that just works with best practices integrated within it. I'm hoping to see that happen even more.
I really like, Sima, how you were talking about eBPF in terms of instrumentation of the kernel, because I think most of the time the literature out there, it pits eBPF with against instrumentation, like they're two separate things. But I think it's right that eBPF is still instrumentation, just on another level. So like, and I'm like trying to explain the difference here, but, correct me if I'm wrong, because I also just have surface level knowledge on this. But my understanding is that the older way of trying to get information, all of these pillars that we're talking about, is instrumentation. So you have some sort of agent that runs on a component or something like that, and it is usually very tailored to that kind of component. Whereas eBPF runs on a micro level to that, because it runs on the kernel, which is something that could not be done before because you had to change the actual kernel code, which is that's a whole other kettle of fish, and it's really complicated. But eBPF is like the JavaScript. If it's like when JavaScript came, it allowed you to run things that you previously couldn't, and in a safe way. That's still kind of like separating it from other places. And also it does it at the protocol level, which is an advantage. It's a different way of doing it, right? But it seems like, even though it's new and hip and trendy, like Pablo was saying, that as much as he likes eBPF, it's important not to forget the idea of observability is to be able to infer the internal state of a system. That requires some form of instrumentation in the code, in my honest opinion. So I think it's like there's this false, I think it seems like they're pitted against each other, but they're really not. They work together, and it's not like eBPF is the new thing and it's replacing instrumentation. Right. It's more like this is another way to get that information, and sometimes it might be an easier way if you can identify protocols rather than different components. Then it's much more efficient.
Yeah, think for instance of like the Parka agent, or Parka as a project in general. It's extremely interesting in that sense that you'd be able to deploy that and you'd have automatic always-on profiling of Kubernetes and systemd, and you wouldn't have to do anything to get that. It would just install it and run it, and
magic.
You would get profiling through eBPF. I mean, it won't always be as detailed or as good as if you're doing it manually and actually instrumenting your application, but it's a quick fix to get something up and to get some additional data in case you haven't done this before.
Exactly. Yeah. Yeah, it gives you that starting point, and then you can start digging into the more specific things if you start noticing issues or as you dig into it.
Same way that with tracing, the auto-instrumentation, is just going to instrument, the bounds, probably your HTTP library or, like your framework and all those things. But you still need to know, business logic, and you need to really instrument what matters to you. I feel everything is a bit complementary. I don't think that, eBPF is a magic bullet that everyone will run on top of eBPF, but yeah, I mean, things are here to stay, to be mixed together.
But it's also
what makes sense.
And it's
Except
also,
for the
I think it's
SNMP
impossible.
traps, that's always going to be the golden silver bullet to everything.
But I also think eBPF is like, it's impossible is going to replace everything, because there's all sorts of custom stuff that companies create that only work for them. That always happens, right? But eBPF is based on like standard protocols. It just makes sense that if you're using these protocols that are super commonplace, then maybe it's easier to just have to use eBPF for those things.
Yeah, and that custom stuff, I think you mean value add, right?
Yeah, I guess so. And I think that eBPF is also a symptom of how complex our systems have gotten. The whole industry is trying to find easier ways to make everything observable. like the ideal is to just drop something in and then it just kind of spiders out, sees everything. Absolutely everything is recorded, but not so much that there's going to be a large performance overhead. And it's all like, we're trying to get to that, right? So all of these are different ways to solve the same problem.
Fully agree with that. By the way, I have two very small trends that I would like to mention if we have time. First one is linking everything together. Simi already mentioned this, but all these kind of telemetry shouldn't be alone. You need to really jump and link all of them together. And I think that people are investing into that. And I'm really excited about that. I think that's really cool. And second one is generating more value from them. Going to a dashboard, taking a look, it's useful, trying to find data that you need at this point is useful. But there needs to be, more tools with, for example, on top of tracing data, on top of metrics data, on top of logs data, on top of profiling data, trying to be, I think, it's not a sponsor or anything, but I think it's cloud. In Performance Insights, we try to give those tips. I feel that it's going to go in that direction, right? Like people trying to be more clever and use all this fantastic data that has a structure.
Yeah.
It's really easy to consume.
Yeah. But yeah, definitely on the linking. So that way then you can see that butterfly effect. If I make one change here, if I stress this system over here, how does that affect all these other ones? It's kind of surprising sometimes what effects there actually can be.
I think the other trend of the observability as a system is also treating it like any other application that also should be, redundant. You have to have some redundancy built into your observability stack. It has to be performant, has to be reliable. Like all of those things also apply to your observability stack. Otherwise, why do you even have it? It's gotten to the point where it's so big that you could have observability outages. So it's possible that nothing might even happen to the application itself. But if something happens to your observability stack, you're flying blind, which is scarier than it ever has been.
Mm-hmm.
Yeah, I think there's two aspects to that you're saying, Nicole, because I fully agree with you. One is that, and that is a trend. I'm not sure whether it's this year, but recent years at least, in that the observability stack or the monitoring or whatever you want to call it is becoming a mission critical piece of infrastructure. That has not always been the case, but that I would say is the case now. And also a trend which is somewhat of a I'm partial, right? Because I'm working on it right now. But self-monitoring of your observability stack, like how is my observability stack performing? Do I have back pressure on my Loki ingesters, for instance, or are they performing they should? And that will definitely become, I feel, more important as well as the observability stack becomes more mission critical. You need to actually be able to observe the observability as well.
Yeah, it's like observabilityception.
Who audits the auditors? Yeah.
But also we just had someone from Grafana Mimir, right, Paul? And we have this joke that like a lot of the usage of K6 in the last few months has been due to Mimir, has been due to them performance testing Mimir. So that's just kind of, that's a funny, I've never seen that before, but it totally makes sense. But, K6 and performance testing is not just for the application now.
And I remember a year and a half or something ago when I still worked at K6 that we had a similar use case where Loki was stress test or performance testing using K6 as well.
Yeah, that's so funny. I have a question about pull-based and push-based monitoring. Do you think that anything has changed in that area?
I think it just depends. In some cases, it makes sense to use one. In some cases, it makes sense to the other. In some cases, it really doesn't matter, and people just want to discuss. So it's true that, for example, in metrics, looks like pull method is being championed by Prometheus, and it's getting some esteem into that. But for example, for traces, everyone is pushing, right? There are no pull implementations as far as I know. So yeah, I suppose it just depends, right?
I spoke with one of the Prometheus authors about this not long ago, a couple of weeks ago, and I think there's been so many recommendations, different recommendations, and like use the push gateway, which no one should do unless you have the short-lived services, right? But I think the conclusion that we came to, at least, was that for getting data out of your actual applications that you are monitoring or observing, usually it's a good idea to scrape that and have something that pre-processes that data and make sure that it's like bundled up into good aggregates, that you're creating time series, applying labels as you should, things like that. And then once you do that, then you can push it to some remote service for long-term storage, for instance. So say that you have a hipster shop somewhere that you want to monitor. You set up a Prometheus somewhere or a Grafana agent, and that one is scraping over there. You're pulling out the data. You're using Grafana agent, for instance, to push it to Mimir or Prometheus, where you keep it for long-term storage. And I think that combination, especially as it allows you to circumvent the need for punching holes in your network boundaries and things like that, that is really going to become a more visible trend going forward.
I think Internet of Things is also kind of, it's a new trend elsewhere, but I think the effect of it is that push-based monitoring is still very much used. So it's like that's how you're going to have to monitor those things. And I know like so many of my things are becoming smarter and it's just getting worse. Everything is going to be interconnected at some point. So I don't know that we can ever really say it's going to be push or it's going to be pull. Or maybe it's always going to be both.
Yeah.
But I do wonder, Nicole, does your smart toothbrush have a metric endpoint? Can you actually scrape it?
I wonder. Maybe it can. It has a very complex API, I'm sure.
Yeah, it's probably registering itself with the service discovery, and yeah.
You laugh. You laugh, but like I have a smart water bottle. You laugh, but I have a smart water bottle that like tracks how much water I drink and stuff, and that actually is queryable. Why someone would want to know that, I don't know.
Then you can graph it in Grafana.
Yeah, people do.
Yeah, maybe we can write an extension for that to load test your water bottle.
Oh, that's
Next
a good idea.
Yeah. And suddenly you notice that the water starts boiling on your desk, like something's going on here.
Actually, we were talking internally about running a load test using my robot vacuum cleaners. So, any other trends that any of you would like to mention before we close off? I think we've mostly talked about most things. I think the biggest thing for me as a tester is the fact that like observability isn't just like a separate thing that other people do. It's like now part of my job. It's, I think it's hard to do performance without understanding observability, right? Because it's really like the other half of it. Testing is super important, and also testing in pre-production is important. But there are some things that you can't test for. It's kind of like what we were talking about. You don't know what you're looking for. So if you don't know what you're looking for, how do you know to test it? And that's where observability comes in.
Yeah, the black box, like boundary testing that load testing used to be, that's not really going to be efficient anymore, I feel, because you're not getting enough information about the system you're probing.
Yeah, it doesn't cut it. Not only for load testing, but for other types of testing. Let's say that you're, trying to do a chaos experiment. How the hell are you going to, create that really target, scope is without understanding like the other parts of the system and getting that data is just from the outside it's just impossible. So I feel that everything is coupling together there. We're going to see more tools trying to remove that gap between the white box and the black box data.
Yeah, it's one of those things I definitely wouldn't want a surgeon to operate on me with a blindfold on. So the
Why not?
observability, yeah, I don't know.
Looks like a fun challenge.
Yeah.
Tell us how that goes.
Yeah, it wouldn't be good.
All right. Well, thank you, Sima, for just coming without any planning. Thank you for joining us. It was fun to have you back. Thanks, Danielle, again. I mean, I'm sure you'll be back still. Yeah.
Pleasure
So
seeing you
next
all again.
week. Oh, I also wanted, before we go, Danielle is talking. Hey, why don't you talk about your own thing? Danielle is going to be presenting in Amsterdam, in the Netherlands.
Yeah, at an event conference. So I'm really excited about that. I will be talking about how to use K6 to test all the things, literally all the things,
All
not
the
only
things.
APIs, databases, everything that you can imagine.
Water bottles.
Yeah.
I will touch extensions. That's going to be fun. Yeah, it will be practical. Maybe a demo. Let's see. How those things work.
Oh, okay. That's brave
The
of
picture
you.
of you on that event page is
I didn't have other pictures.
That's great. Also, next week we're going to have Marie Drake. She's I think the newest joiner of K6, but no stranger to K6. She's been on office hours before, but she's going to be on next week to talk about her experiences in joining K6 and what she thinks of XK6 browser. Hopefully, it's good things. She's kind of stuck now.
Yeah.
But thank you, everybody, for watching. And thank you three as well for joining me.
Thank you, Nicole.
thank you.
Bye, everyone.